Okay, so good morning, guys. We are going to look at the discriminant. So if you look at chapter 2, you will notice it goes through solving quadratic equations, be this by factorizing, completing the square, or by using the quadratic formula. So if you do want to go over them for a bit more practice, that is perfectly fine. Okay, so I have put chapter 2 onto the classroom so you can do that there. Today, we are just going to look at the discriminant. Okay, so when I have this fabulous equation, okay, so you should remember this fabulous equation. If you don't worry, it's written on your IGCSE, but you will probably remember it because if you do it often enough, you usually remember stuff. Okay, but when we are looking at the discriminant, we are looking at this, okay? So at IGCSE, they're usually only sticking to stuff that gives you a solution. What you are now going to learn is that the discriminant, which is what this part is actually called, is the part that will tell you whether there is 0 roots, whether there is 1 root, or whether there is 2 roots. So if I have a quadratic, let's just do it that way, how many roots do I have? So what are my solutions to this one? Well, I've got 1 there and I've got 1 there. So that would be something that has 2 roots. If I have this, what's my root? Where does it cross the x-axis? It crosses the x-axis at this 1 root. So I don't know whether you recall where I was talking about a repeated root, because you might have something like this. And so it's the same root twice. So it's a repeated root. So that would be a 1 root or repeated root. And then last of all, you'll get something like that. Okay, so, or alternatively, actually, if you've got negative ones as well, let me just draw in the negative ones. A negative one might look like that, where there's 2 solutions. That's 1 solution, or it will just be all the way down there. It doesn't necessarily have to be in these quadrants. It could be anywhere on this graph, okay? So the way to find out what happens with each of these is if I look at this discriminant, it's a nice shortcut way to tell me whether it's going to be like this and there are 2 roots, whether it's like this and it gives me 1 root, or whether it's like this and it's kind of otherwise floating above or below the actual axes, and so you don't actually get that root, okay? So when we're asking about roots, we are talking about the x-intercepts, okay? So from this discriminant, if the value is a positive and it is more than 0, you will always have 2 real roots, okay? If it is equal to 0, then you will have 1 repeated root. And if it is less than 0, then you will have no real roots, okay? You guys don't really need to worry about real and imaginary, but if you are reading about it, you will find out that there are real and imaginary numbers. Okay, and if you were looking it up on your calculator, then your calculator, so say if you tried this on a standard calculator and you just went square root of -1, you usually get the mass error, right? But if you go into, this is called complex mode, and I go into that, then I would say, what is the square root of -1? It would then tell me that it is I, okay? So that is just imaginary roots. So when we are talking about 2 real roots, 1 repeated real root, and no real root, we are kind of just talking about it within the real plane, and we're not introducing the imaginary plane, which you won't have to do until you go to university. So don't worry too much about this. Okay, unless you do 2 maths A-levels, then the second maths A-level will cover the imaginary numbers. Okay, but just in case you do feel like researching online, you will probably notice that it does have I. And I know some people, when they're using this calculator to solve some of the equations, especially when you go further in and you get the cubic equations or the quartic equations, you can use the calculator to help you out, and then you will notice that I does usually appear. Okay, so getting off that, because you don't necessarily need to know it, you are going to practice your discriminant knowledge with the questions that we have. Okay, so looking at these questions, it says calculate the value of the discriminant for each of these 5 functions. When they say functions, they're basically just saying y equals, okay? Do you know when I have this graph? This is my function. You should remember it from when we were doing functions. So I could actually write this to say, well, the output will be this is the input, okay? Because y, what is y but the output of whatever we put in for x? I would say, oh, when x equals 1, this is what y would equal. And it's the same thing. So when they're talking about these functions, just remember it's like saying y equals. Okay, so we'll go through a couple of them. For part B, I'm going to let you try that by yourself. That's a little bit of your quadratic knowledge. For part A, I'll go through a couple of them. And then I'll do one of the questions down here, because all it's doing is just being a bit wordy. Okay, so I've got function x equals x squared plus 8x plus 3. Okay, so if I had to write this out in the mode of ax squared plus bx plus c, which is just your generic quadratic equation, I need to find a b squared take away 4ac, okay? So this is my b, so that would be 8 squared, take away 4 times a, which is 1, times c, which is 3. So that would be 64, take away 12, which is 52. Okay. So that's saying calculate the value of the discriminant. So all they're asking for is the value of the discriminant, which is 52. If you did have to say how many roots there were, you would say there were 2 roots because it is above 0. Okay. So if you did have to make some sort of statement, you can say as b squared take away more than 0, there are 2 real roots. Okay, or you could kind of, as long as you make some sort of statement about how the discriminant is positive, and so there would be 2 real roots. Okay, so that's only if they ask you for a description. Here, they're only asking for the actual discriminant. So when they're talking about the discriminant, 52 is fine. You don't need to make a statement. But if they do ask you to make a statement, you'd say something like that. Does that make sense? Okay, so I've done that one. You guys can do the rest. It's fine. And then one down here. Let's try one of these. Oh, I didn't rub everything out. Okay. Okay, so it says find the values of k for which blah blah has 2 real solutions. Find the value for t for which has exactly 1 solution. Okay, so I'll just do number 2 because it's up there. So I've got x squared plus 6x plus k equals 0. Okay, so it's saying 2 real solutions. So what do I know the discriminant needs to be in order for this to have 2 real solutions? Well, I know that b squared take away 4ac must be positive. It must be above 0. And my a would be 1, my b would be 6, and my c just equals k. Okay, so I've got b squared, which is 36, take away 4 times 1 times k, which needs to be more than 0. So this is 36, take away 4k is more than 0. That's fine. Now, when it says find the values of k, well, we've got an inequality. So even solving the inequality would still be a solution. Okay, so I'm just going to add 4k to both sides. So I've got 36 is more than 4k. So k is less than 9. Okay, you could leave it like this, or you could write k is less than 9. However you want to say it, it's perfectly fine. It could be that or it could be that. But even this is the solution because it's saying find the values of k. I know that k just needs to be less than 9. It could be any value less than 9. because that's the inequality. Does that make sense? Okay, so that would work. Whereas, say, for 3, it's saying exactly one solution. So I wouldn't be applying this because I only apply the discriminant is more than 0 if it is 2 real roots. If it is one solution or a repeated root, I would say equals 0. And if there are no real roots, then I'm going to use the inequality is less than 0. Does that make sense? Hopefully it does, okay? But the discriminant is a nice, easy way just to determine whether there's anything that crosses over. So when you start looking at simultaneous equations, you can even do the same thing with simultaneous. If you rearrange the equation and then find the discriminant, you'll actually find out whether they actually have any intersections between those two functions. Does that make sense? So it kind of leads up to more maths where you're just combining all those different topics together. But hopefully that should be okay. So I'll let you get on with this exercise. And if you're able to cover it, you're pretty much all good. Okay? And then next lesson. When is next lesson? Tomorrow. Okay? And then tomorrow we'll start looking at the alpha and beta because I just want to spend a bit of time on it because I know sometimes people like to spend a bit of time wrapping their head around algebra, which is all good. Okay, so take care, guys. Make sure you get some sun, some vitamin D, and stay safe. Okay, toodles.